This really called number 300, longest increasing subsequence. And for this question, it give us an integer array and return the length of the longest strictly increasing subsequence. So the subsequence, the difference between subsequence and subarray is that subsequence, the data cannot, it may not be consecutive, contiguous. So you see, we have for this answer, the longest is 2, 3, 7, 100, and 10. So for this kind of things, intuitively, what I think about is just using DP, right? Use dynamic programming for every we have for example int and dp equals new int a, right? So n will be nums length. And the DPI will represent for index I the longest increasing subsequence, right? So that means that is end from I. Then what we need to do is that we are to for int j equals I minus 1, right? And minus 1, j is smaller, greater equal to 0, j minus minus. Then we have we are going to have something like but have a DPI, right? DPI equals minus the thing is that if nums j is smaller than nums, right? Then we can add those kind of nums I to the longest end with j sequence. Then we'll have something like DPI equal max BPI and BPJ plus 1, right? And for every I, we are going to have a longest increasing, right? And we can have a global max and compare and also have the global max, right? Max result equals max BPI and max. And in the end, it will just return max. For doing like this, the time complexity, because we are using 2 for loops, the time complexity will be O(n) squared. Space will be O(n). And there is another approach for this kind of question is that we can greedily do some using greedy way, right? So if what we are doing is that we have a list, and for every number, we try to find the first numbers in this list, which is find the first number which in this list which is greater equal to this number. For example, if in this list we have 3, 2, 3, and 4, and 6, 9, right? So now, if we already add these numbers to this list, now if we have a number 6 coming, right? Then what we need to do is that we find the first greater equal to 6, that is this number, and we replace this number with the new one. Okay. And if we cannot find the reason we're doing that is that, for example, we come out 7 here, right? Is we find the first one. So 9 will be replaced by 7. In the next case, if we have an 8 coming, we can put the 8 after 7, right? For example, there is a 10 or something like that. And in this case, we can form consecutive subsequence greedily. That is we find the number, we can replace this number with a smaller number and does not minimize the LRS length, right? So in this case, it can give more spaces for the upcoming number, which can form a longer LRS. So what we do is that I'm going to write the logics. Is we use list pair and find the first number in list greater or equal to none for every number in this number nums array, and replace the first number with none. If not found, just append this number to the end of the list. So based on this kind of greedy mechanism, we can write the code. And doing like yeah, so based so the first step based on what we write, right? So we'll have a list of integer list for new array list. Okay. And for each nums, we are going to get the index of the first number, which is greater or equal to this num. Okay, we'll write a help function binary search on this list on this num. Okay, so we'll have the list set this index as this number. So if we are not able to find, that means that if do this kind of binary search, right? If we not find, we just will have it in binary search list or integer list into none. Okay, if we are not find the first index which is greater or equal to this one, that means either this list is empty or all of the elements in the list is smaller than this number. So we return -1. For these two cases, we append this number to the end of the list. So I say if index equals 1, right? Equals -1. We'll just append the list at this number. Otherwise, it just has this set. What's the element? What's the number in the list, which is greater or equal to none? Okay. In the end, what we need is just return this list dot size. Okay. So we can draw this binary search quickly, right? So if this number list is empty, we'll return -1. And we'll have start equals 0 and equals list dot size -1. Okay, we'll have while start +1 smaller than end need equals start plus n minus start divided by 2. Now we want to find the first element in this greater equal to, right? So let's say if this get none, if this one equal to none, okay, get a need, sorry. That means we want to find the first one greater equal to. So that means we should still search to the left. Then we'll have end equals to mid, right? So this one is greater, also end equals to mid, right? So else that is start equals to none, right? So we'll write if this one's smaller than none, start equal to mid, else end equal to mid. Okay. So in the end, we want to find first. So if after we jumping out of the while start is 1, that's before to the end, right? So if let's hit start is greater equal to none, return start. And if the end, right? So that means start does not equal greater equal to none. Then we want to see compare the end. If the end greater equal to none, then return. If the end does not, that means both start and end does not meet the situation, right? We just return -1. So this is the binary search approach. Okay. Doing like this, the time complexity will be n log n is better than dPo n square time complexity. Space complexity will be O n. We have a list.